Okay, so welcome to video 5 in this introduction material on data visualization with R. So here we're going to talk about gghighlight and gganimate, which are two examples of packages in RStudio that we can use to extend our graphical display of information. So why would we want to use a gghighlight first of all? So if we think about different types of data here, and here we have different students, and you can see that there are changes in scores between two different exams has changed. Some have increased and one in particular has decreased. In this kind of instance, it depends on what kind of message we're trying to communicate to the viewer. You see that the change between the different people here is generally positive, but also maybe hard to read this graphically from the graph. We could encode this as a table, but again, that may not always be communicate this message very quickly in a short amount of time. So here, what we're trying to do by highlighting this person, we can clearly indicate that their pattern is different from the other students. So the contrast is between this red highlighted area versus the ones in black. So you can see the ones in black all have the same trend. To improve this, we can even separate even out from the others, so it's more clear that there's a distinct pattern here. Indeed, we could show the rate of change for even compared to the other students. That would also be a way of looking at this. So the advantage of gghighlight is that we don't show different colors, for example, for each student, because that would emphasize them all, and that might be relevant in certain instances. Here we're highlighting the key one that's of interest to us. So we take the same principle for gghighlight, and we use our typical setup for ggplot, where new one is a data set we're looking at. We look at the year versus the log value on a y-axis. We're grouping them by their names. That's the key variable of interest. And then we can color them as well. We can add lines with some transparency and plot them, and we'll get something like this. You'll note here there's a bit of a gap between 1997 and 2006. That if we did more parsing on the data set, we could remove those. But you can see there, if we plot each line and color them differently, somewhat differently, that is still very, very hard to read and make sense of what's going on. So you can see that there's more structure at the start, and that kind of decreases over time. It becomes more mixed. So what we will do in the lab, in the demonstration and video associated with this, is install the gghighlight package, and that will allow us to add on certain things onto this. So what we can do for this kind of large data set, because there's many names with a relatively low abundance per year, and this may not be informative in terms of a model of trying to communicate about the most frequent names. So what I might do is cut out the names which are more rare initially. And to do that, we can use dplyr. So we can use taking a new one, pipe it out to filter those the frequency of at least a 10 per year. So the second names with at least at least 10 entries. We have the same lines here for taking that data. So we don't have a new one at the start here because it's already piped into here. So this pipes in that data set into ggplot. And then we add on our function gghighlight, and we're selecting the ones with a mean value greater than 600 in this instance. We could have other criteria. There are other numerical criteria based on value. We could have things like a particular name that's of interest, name equals Mary, for example. And we could have names with a maximum value of at least, say, 1,000. Those are the criteria that we put in here. We're also adding a theme of a minimal, just to make it more easy to see, because we got a lot of complex diagram here. And that's something we'll look at in the demonstration videos too. So if we look at what we get from this, we can see that many of the names, the lower frequency names, are now grading. And this means we can focus our attention on the most frequent 5 names in this case. So our ggplot has automatically determined that we're looking to look at the most 5 frequent names here, which are James, Michael, Patrick, and David, based on their initial frequencies. Sorry, their average frequencies of being at least 600. You can see there it's quite easy to visualize their trends. So we can highlight them quite easily and see which ones are of interest, even though it's a complex graph with many different things going on. So you can see it's been changed from a log scaled one. And what you can see there is that there's John fell dramatically in frequency in Ireland in around 1979. There's a big spike because of a Pope's visit where his name was John Paul, hence a lot of Johns peaked then. You see then the frequency of David kind of was higher around the same time, that the Michael has generally gradually declined Same with Patrick has generally declined. And then James has shown a slower rate of decline as well. And you can see that there's other names that became more common recently, but they have, their average number is still below 600 over the time period for which we have data, bearing in mind there's certain years with caps as well. And we can take the same data set and look at ggAnimate. So ggAnimate has changed the structure over the past few years in terms of how we're using it. So we're going to look at the most recent version. To look at this, we're going to use just the Irish girls' names. And for all these packages, we want to use tidy data. So we're taking our initial data, which is the wide format with the rows and columns spread out and something like that. We're using the gather function to gather it together by year and value. So we have each name as the first item. Then we have the years for which there is data. And then we have on the third column the value associated with that. So it's very simple for each row, but there's many rows. So it's the long form of the data, tidy data. And do that for each year for which there's data available. What we're going to do for our purposes here is, well, firstly, remove the X from the year to make this numerical, and then subset for ones where the value is at least 500. Because there's a lot of data here, so we can't visualize them all. So there's just an illustration how we can look at the most common names using ggplot animation. So when we do that, we'll get this kind of graph. So you see Anne 1964, 866, and so on for all the different values. So we can take the same structure we had before. ggplot looks at xg4, plotting year versus the log value. We have the geom point. Then we add geom text. So that's taking the names in our table. It's coloring by the name. That's nudging them so that the names are not directly beside the points necessarily. Checking for overlap where possible, and we can scale the size as well. So if we do that, we get this kind of plot, which is okay, at least in identifying which is which, but maybe not the best because we've no line here and the names are not exactly beside the ones. But you can see that you can add name annotations onto this kind of plot. What we can do is the key function to make things animated is this function transition states in the ggAnimate package that we would have installed. So if we do that, we can include the year, and that's the value across which we wish to increment the frames in the video. So if we look at that, we can see that reframe is changing there. It goes back to the start with Mary at the start, then Catherine, Margaret, Caroline, Emma, and so on, different names appearing all the way up to 2015. So this kind of gives a big animation over by just taking this graph we had before and just spreading it out for each year. And we can add in other features as well. So you can see here that we have, in this graph, we're looking at two functions, shadow wake and shadow mark, which indicate that we leave the old marks here. So you can see these old marks are left there for the old names. You can go see the previous trend. That's for Mary, for example, showing the shadow marks. So, and there's other things that it enters as a fade and exits as a shrink. That's just cosmetic effects. And then we're doing this by year by year. So you see that the old years are retained and we're adding it in as you get more years. Sometimes that will make it easier to see these newer years as they come through. Although it maybe is not the best animation because it's changing too much perhaps. So we'll explore these more in the demonstration videos. Please view those more to see how else we can do this.